Previous three videos, we have looked at training image classification models using inbuilt algorithms and also other frameworks such as PyTorch, right? And then we looked at training object detection model using Sagemaker's inbuilt algorithms. Okay, today we will train an object detection model using the same SSD single shot detection algorithm, but the TensorFlow framework. Okay. All right. Please watch the previous three videos. They cover almost all the concepts. So in this video, we'll try to keep it short and we will cover only what is different. Okay. So as you know, object detection, we try to identify the objects within the images, and each object we identify using coordinates in different formats, right? So let's start. Okay, here I have already prepared the data. Now this is again different. So for the four models we are training, the data format is different. Okay. So for this one, we'll have the train channel or the train path. It should contain this annotations.json file and then another folder with name images, and our training images are here. Okay. So it will take this train path. There should be two things. One, the annotations file, and then the images. Now this is different from inbuilt SageMaker model, right? Where we have, let me see if I can show you that. All right. Where we have the train images as well as train annotations, and we had one file for each image. Whereas for the TensorFlow model, the input format is different. We have the images and then a single annotations file. Both should be sitting in the same folder. Okay. All right. Now let's look at the format of this file. Okay. This is for inbuilt SSD model, which we have looked into it in detail. But now for the TensorFlow, this is how it looks like. Okay. So here we have, it has two elements, right? It's JSON file. First one called data, and it contains the number of elements as many as the number of images. Okay. So the first one, the image name, the height and width of the image, and then this ID. Okay. So this ID is just the serial number. Okay. So if we are comparing with this file, so basically the data part contains the image name and then the width and height of the image. We don't need to provide the depth, but it contains this serial number as this image ID, right? So that's the data part. And then it will have the annotations part. Okay. So the dictionary contains two keys, data and annotations. Now the annotations, it will contain the image ID. So this image ID is to map the information between annotations to the data. Okay. And then we have the box coordinates. Okay. Same as before. So the top left coordinates, and I think then the width and height. Okay. And then the category or the class ID, which is either 0, 1 or 2, because we have only three types of objects. Now, as you can see, this format do not contain the class name, right? Which is for inbuilt SSD model. Okay. It contains only the class IDs. So that's how we prepare the file. Now, the reason why this image ID start from 36 is because this is the validation file. So we have the 36 images for training, and the train file contain the index from 0 to 36. I believe 1 to 36. Again, this is incorrect. It should start from 37. Okay. So when we have such conflicts, SageMaker probably ignoring such images and the corresponding annotations. All right, let's go back to the code. Okay, so we have prepared the data, and then this is inbuilt. Okay, all right. Yep. So as we were discussing before, these are the parameters. Otherwise, the rest of the code will be exactly as it is. But as you can see this time, we don't need to supply the number of images or the number of classes. I think SageMaker should do the same for its inbuilt algorithms also, because this information can be inferred from the input data we are providing, right? All right, so these are the two hyperparameters we are supplying. And then, so the code will be very, very similar to the image classification model using PyTorch framework, right? So first we extract or retrieve the image URI, okay, by supplying the model name and the model version. So the model name is this TensorFlow object detection one SSD. So it's still the SSD model, and the features are extracted using this ResNet 50 that act as a head. Maybe we will have separate video on what are all these different models, what is different about them, how they work, etc. But that might involve quite technical details. Okay. All right. And then we extract the source URI which contain the entry point. So when we do the training, this will be transfer underscore learning.py, right? So this zip file will have that file. And then the initial model artifacts, basically the weights. Okay. So if you extract this file, so when you run these two commands, okay, when you run this one, you are simply extracting or finding out this string. Whereas when we run these two commands, we are downloading these two files. Are we downloading? No, we are not downloading, but we are accessing the data from these two paths. Okay. And this one source directory that contains the entry point file. If it's training, that would be transfer underscore learning.py. If it's inference, that would be inference.py. And this contain the original model artifacts. Okay. Then we define the output path. All right, we extract the default hyperparameter by supplying model name and version. And this model, it has a bunch of hyperparameters. And if we want to change any hyperparameter, we can explicitly set the value. Okay. Again, the important ones. Sorry, 1 second. Early stop writing initial accumulation. Train only top layer false. As we are doing transfer learning, should this be true? I'll check that. Train only top layer. I think this should be true, which is the case for image classification. So let me open that file. So classification using this. Now, so this is the image classification we did through transfer learning. So train only top layer true. Okay. So if we want to do transfer learning, I think then by default, this variable seems to be false. So what we need to do is we need to do hyperparameters and then train only top layer. We must set it to true. Okay. Then it will be transfer learning. Otherwise, we are training the model from the beginning. So even the head layer weights get learned from the data we are supplying. Okay. Then this optimizer learning rate. So all this we can leave as it is. Okay. and the number of epochs. So basically we set two hyperparameters. One is this, the number of epochs, and then we are enabling the transfer learning. Sorry, I thought this is by default true, right? Because in most cases we want to do transfer learning. So this should have been true by default. Okay. All right. So I have trained the model with this variable as false. So that means the model will have very, very poor accuracy, right? That's all the difference, but the process is exactly the same, right? And then we get the estimator. Some of these variables, as you know, already are fixed. What changes is this image URI, and for non-inbuilt algorithms, we need to supply the source, and the source, along with the source, will have the entry point, which is this transfer learning.py, and then the original image artifacts, which contain the model weights. Okay. The instance type, the hyperparameter we set explicitly, and then the output path. Okay. So I'm trying to make the video short. We are going it quickly. Now this is important, and this is different from the three prior videos. Now, if you look at the train, so here the path contain both the images as well as the annotations. In earlier cases, those two were sitting in different folders, right? But whereas here, both of them are sitting at the same location. Okay, so here we are supplying the bucket prefix and then train. Now this is important, right? This slash is very important. Okay. All right. So it will read both the train images as well as annotations from the same location. Now, I think this model, it can take only the training data, and by default, it split the data into train and test with 80 to 20 percentage of the data. Now, when I tried to run the model by explicitly providing the validation data, I think I got some error. It could not understand what this variable means. So we only supply the training data. Now the model automatically dividing it into train and test, and during the training process, it's checking the performance on the test data. The model has split. Okay. All right. Then the job name, and then simply do the fit, the standard method. Okay. All right. Again, all these things are standard. We have seen 3 times by now. Somewhere in the logs, it says I am dividing the data into train and test with 20% keeping for testing. Yeah, it will be somewhere in these logs. I saw it. Okay. All right. So the model gets trained. Okay, so this is explicitly saying I have uploaded the model artifacts back to S3 location we have provided. And then the inference, as we were discussing, for these models using other frameworks, the train instance URI and the infer instance URI or the Docker image will be different, right? So that's why here we are explicitly retrieving the Docker image for doing the inference. Again, the model and model versions will be the same, but whether we are doing the training or inference is different, and we have different Dockers for that. Okay. And similarly, we are extracting the entry point script. Okay. So this would be inference.py. It takes exactly the same variables. I mean, the model ID and the version. Okay. Only the scope will be different. Now again, can you guess why we are not extracting the model URI? The reason is we just have trained the model. So we already have the model, with the weights fine-tuned for our data, right? So when we deploy the model, the estimator, it already know where our model artifacts are. Okay, so it uses these two pieces of information and the model artifacts sitting on our own S3 to deploy the model. Okay, so again, we specify this entry point as well as the source directory. The source directory actually contains this script. Okay, so here we are just saying here is the folder, but within that folder, the file name is inference.py. Okay. All right, then the inference instance type and the count, that's a standard thing. And we are providing the names. It is doing the standard three things, creating the model, config, and actual endpoint. Now the inference is exactly the same as we discussed, whether it is classification or object detection, or maybe we will look at other use cases as well. There are a few different variants for the segmentation, few tasks similar to that. We will cover those as well. All right. So here we have the output format. Again, we will discuss this in more detail later, because we are going to analyze this data, compare against the ground truth to find out the model accuracy, etc. But it seems like it has these two values, those normalized boxes and then the scores. So these are all the detections, meaning we need 4 values. Now this is rubbish really. So it's simply saying 0 to 1, 0 to 1. So the full image, that's again because it's not transfer learning and we train for only 5 epochs. So the model hasn't learned anything. Okay, it's rubbish. Okay, so here we have the classes. Okay, so we have 3 values, right? The boxes, the classes. So it's saying it's this class 3, and then probability for each class. Okay, now as we discussed, object detection model, they return a number of detections. Okay, 90% of them with very low confidence score. Now when getting the response, here itself we can restrict how many detections we want. So here we are saying I want the number of predictions to be only 5. There is probably an option to say, okay, I want predictions with a score above a certain threshold. Okay, so there may be another method, other way to check or to restrict the number of detections returned. Okay, again, don't forget to delete the endpoint. Okay, so a quick summary of the 4 videos. We have trained image classification, object detection models using inbuilt algorithms and external frameworks. So in the next series of videos, we are going to work on how to prepare this data, right? How to prepare the data, how to create the annotations, etc. So that's the first set of videos. And in the follow-up videos, we will work on how to assess the model performance. So we are going to take the predictions as well as the ground truth, and we will compare it to find out the model performance. We will measure it using various metrics like classification, accuracy, the confusion matrix, the precision, recall, true positive rate, false positive rates, etc., etc. And also for object detection models, we can have different thresholds for different classes. For example, let's say identifying dogs is easy. So the model might detect dogs with very high accuracy. So we might say, hey, if my confidence score is only above 80% or 0.8, then only I take that as a detection, right? If detecting cats is difficult, we might choose a low threshold value, right? So we are going to discuss all that. So we are going to, for various thresholds, we will find out the precision, recall, and how to balance the precision and recall, how to choose different thresholds for different objects, etc. So we will cover all that. Okay, so we have covered only the training model. we have skipped the data preparation as well as the post processing or the model assessment, which is the most important step. That's all for today. Thank you very much.